Okay. So today we'll learn about the page replacement algorithms. As you know that in paging techniques, only few pages reside inside the RAM at a time. Uh, but not all the pages yeah, from a process reside inside the RAM. Only few pages reside inside the RAM at a time during the execution time. So what's happened when a page is not available inside the RAM? Then if the page is not actually available inside the RAM, that times from a page table entry, page interruption bit set as a 0. That from there actually your OS can understand that this page is not currently available inside the RAM. So it needs to replace this page. It needs to actually replace this page from disk to memory. It needs to replace one of the page. So how we can replace a page? We actually learn this kind of algorithms today. Okay, let's see. Okay, let me share my whiteboard. It will be okay, share the screen. Okay. Okay, let's see. In here, one page replacement algorithm is there are two types of page replacement algorithm. Page replacement method. We can say this is not algorithm. Say page replacement method. We can say local. We can say actually in general page replacement method. So it can be approach can be local page replacement. Another is called global page replacement. One is local page replacement, another is global page replacement. So what is the local page replacement? Let's see, in local page replacement method, page replacement occurs only within the frames of a particular process or own process of own process. What does it mean? Let's say you have let's say currently your operating system is running total 3 process P1, P2, and let's say P3. This 3 process is currently running. This is your computer's memory, or you can say RAM, whatever it is, RAM, and you allocate for process P1, you allocate total three frames. For process P1, you allocate 3 frames inside the RAM. So here is this frame is allocated for process P1. Let's say this is for process P1, and this is also for process P1. And process P2, you allocate, let's say your operating system allocates 2 frames for this process P2. Even though there are many pages, only 2 frames is allocated for this process P2. And another is process is called the process P3. Here is also many pages, and this process also gets total 2 frames as well. Total 2 frames. This, let's say these 2 frames for process P3. So let's say after a certain times, sometimes later, your CPU asks for a data for process P1. For process P1, even though there is a total 3 pages is available for let's say this is page number 0 is in here. Page 0, this is 1, this is 2. This is 0 number page, this is 1, this is 2. After a certain period of time, your operating system asks for this data for this from process P1, but this data, let's say, is available in page 4. Page 4 is not available in here inside the RAM. So what your operating system do? Your operating system will replace one of these pages from the computer's RAM. Okay, so which frame it will replace? In local page replacement algorithms, it can replace with its actually own frames. It will replace by using its own frame. Okay, so when P1 needs to replace a page, so it will replace within these three frames, because these three frames is allocated for this process P1. It never touches to others process frame. This frame, this frame, this frame, it cannot touch, because this frame is allocated for process P2 and P3. So page replacement occurs within it with actually with own process. With own process. Let's say process P1 allocates these three frames, allocates for these three frames. So when page replacement occurs, so it will replace by using only these three frames. It never starts any other frames. Okay, this is actually local page replacement. And then another is global page replacement. From here, if you know the local page replacement, you can also understand what is global page replacement. In case of global page replacement, when actually replacement is needed, it can replace actually any pages inside the inside the computer's memory. Okay, it can replace any pages. It can, let's say this if it is global page replacement, what's happened in global page replacement? Of course, there something called this priority basis. Let's say priority for process P1 is greater than P2 and P3. When it is global page replacement, so process P1 and its priority is high. So what's it will do? It will replace the page from P1, P2, P2 and P3, because its priority is higher than P2 and P3. It actually needn't actually replace its own pages. So it will do? It will actually replace the page from either process P2 or P3. Okay, so this is known as the global page replacement. In case global page replacement occurs across all processes. Okay, when it requires for a particular process. From here, actually nowadays in operating system mainly follow the local page replacement, not the global page replacement. That is one problems for the global page replacement. So let's see what is the problem for global page replacement methods. Okay, let's say you have total three processes. Also this is your computers. This is the RAM or memory. It contains, let's say, 1, 2, 3, 4, 5, 6, and 7 frames. Also, this is one process. Let's say 1, 2, 3. This is the page. Frame is the partition for memory, and page is partition for processor. And frame size is always equal to your page size. This frame size and page size is always equal. You know about this. 5, 6, 7, 8. Let's say this process contains total 8 pages, and here is another two process P1, P2. Here is also this is P1. Here is also 1, 2 pages for process P2, and another process is called process P3. Here is also, this process also contains 2 pages. So now let's see process P1 is higher than, priority is higher than P2 and higher than P3. Also, let's assume that P1 and P2 and P3 is process currently running. It means that the pages is now from these two process, these 2 pages, 2 plus 2, total 4 pages is currently resides inside the RAM. Let's say these 2 pages for process P2 and these 2 pages for process P1. This one and this one for process P1. Okay, this is for process P2, 2 pages, and 2 pages for process P1. These are currently running, but when and after a period of time you open a new process. This is called the P1. Also its priority is higher than others two process P2 and P3. If it is higher, so what's it will do? If it is global page replacement, it will take all the pages. It will actually it will actually allocates all the pages by its sorry all the it allocates its own frame, own pages, all the frames. Okay, it will take all the frames that are currently available inside the memory. So here is total 7 frames, so it will take all 7 frames because it's priority high. So here P1 P1 page P1 allocate for page 1, 2, 3, 4, 5, 6, 7. Total 7 frames now is all for process P1. P1 all for process P1. Now P2 and P1 is write back to the disks. Your hard disks, write backs to hard disks. It gives the allocate for process P1 because P1 is it has higher priority. So what's happened here is also extra one pages is required, but here is needs to for execution here needs total 8 pages, but here is it can inside the memory it can allocate only 7 pages. So now see here this is it's this process its priority is high, but it cannot allocate because a frame is not available. Frame is not available. Here is it requires more frames. But these two process was executing, but it's currently is right back to the disks. Due to the higher priority, this process cannot execute, and this too is right back to the inside your computer's hard disk. So no process actually cannot run in case of global page replacement. But if it is local page replacement, actually when this process is open, even the there is no priority when it's open, so you will allocate the frame for this process that is total 4 frames. So it will take only four frames from here, 4 frames from here. It never touches P2 and P1 frames. So it keeps it actually allow for execution for others to process. But if you apply for global page replacement algorithms, actually no process, sometimes it can happen this no process can actually execute. So this is how in recent day we usually use the local page replacement. When a process runs, it allocates the frames, number of frames, and also when replacement is needed, it just replace with its own frames. It never touches the others process frames. Okay, this is the local and global paging techniques. So let's see. Oh, any questions or comments? Okay, let's move forward. There is another very important concept for paging algorithm. It's called demand paging. Demand paging. Also keep your note that because it is also important concept for your next exam as well. So demand paging, what does it means? The demand paging. The process loaded inside the RAM when it's requested for. So what does it mean? The process, it means the process demand paging should refer as the page of a process is loaded inside the RAM when it's requested for. Actually, when it's request, once you request a page, then it will load inside the RAM. Otherwise it won't load any pages inside the RAM. This means that when you open, let's say this is the RAM. This is the RAM. Even though these all frames are currently empty, so you open a process. Called, let's say, process P1. It has total. Let's say this is it. It has total 4 pages. 1, 2, 3, 4 pages. When you open this process, at the beginning of execution, no page is loaded inside the RAM. When CPU request for the data, let's say process it's at CPU request for this data from page P3, then P3 will be the loaded inside the RAM. Of course, of its own frame. Let's say you allocate your operating system allocates for this frame total. Let's say total four frames allocates for this process. But at the beginning, no pages are loaded inside the RAM. No pages are loaded inside the RAM. This is demand paging. When actually CPU asks for this data, then it will keep allocates a single page. Okay. At the beginning, no page loaded inside the RAM for demand paging. So keep in mind at the beginning, no page loaded inside the RAM, even though RAM is empty. Okay. When let's say now this page is inside the RAM, and then again CPU request for this data, but this data is inside the page number 1. Then OS will load this page. So what's happened? What's happened in here? There is no pages inside the RAM at the beginning. So when CPU requested for this data for a particular page, let's say data is data from the page number 3 of process P1. But when CPU request for this data, but data is not available inside this page is not available inside the RAM. Means there is a one page fault, and then your OS will send back to the page 3 from your DEX to memory. From DEX to memory, it will send DEX to RAM or memory. So at the beginning, of course, there is a one page fault in case of demand paging, but this concept, this demand paging, actually very popular nowadays. Also, this type of concept is used in operating system, demand paging. At the beginning, no page is loaded inside the RAM, but when it is needed, then it is start to loading inside the RAM. Okay, this is known as the demand paging. Now let's see some main topics like how like the page replacement algorithms, how we can replace the page from memory to disks. Okay. There are different types of page replacement algorithms is available. We will explore all of them. These are not actually too difficult. It is kind of easy. I think one of easy concept, but you have to actually look at carefully. So this is also important for your exam as well. So one is list recently use or LRU page replacement algorithm. Two is, let's say, one is the FIFO, first in. You already, I think, familiar with first in, first out. If you know about the queue, I think you work on the queue is taken queue, first in, first out. FIFO page replacement algorithms. And then similarly, if it is stack type is last in, another algorithm is last in, first out. Or LIFO page replacement algorithms. And another is most recently used, or now it is MRU page replacement algorithm. And 5 is optimal page replacement algorithms. OPR, optimal page replacement algorithm. There are 4 types of algorithms we'll explore in our today's class. So what is the list recently used page replacement algorithms? when a CPU requests a byte or word, you know that always CPU request for a request for a word or byte for to execute a process. Uh, let's say when a CPU request a bytes or word that is not present inside the RAM. Okay, when it is not present inside the RAM, of course, this data is available inside your hard drives. Okay, or disks. In disks, everything is available. In hard drive, every data, every point is available. But inside the RAM, there are not all data or bytes are available at a time. Okay, so when CPU request for a byte or data that is not present inside the RAM means there is a one page fault. And then OS will replace, in case of LRU algorithm, OS will replace the page that is recently accessed by the CPU. Sorry, that is least recently accessed by the CPU. This one least recently accessed by the CPU. Least recently accessed by CPU. List. Okay, recently used by accessed by the CPU, that page will be replaced. Okay, so let's consider one example. It will be more clear, I think. So let's consider the following page reference by the CPU. Let's say CPU reference for a particular process. Let's say this arbitrary process. So CPU actually request for page 3 first, then 4, then 5, then 1. Okay, let's my pen. Okay, let me change my pen. Yes. Okay. This is for another, again 4, and then it's 5. Let's say it's continue. Then it's 1. Then CPU export 2, and then 4, and then 2. Okay. CPU actually request for this this kind of string. Let's say page string actually request for request actually by the reference by the CPU for a particular process P1. Okay, it's 3. At first it requests for 3, 4, then 5, then 1, then again 4, again 5, again 1, then 2, then 4, then 2. Okay. Now let's see. This is your memory or RAM. 1, 2, 3, 4, 5, 6. Okay, whatever it is. This is what also this is for process P1. In process P1, you see, in process P1, let's say there are several pages. Here you see there is total 5 numbers, so there should be 5 pages. Also in here, you see, let's say for process P1 is allocated for total 3 frames is allocated for process P1. 3 frames, total 3 frames. So at a time, 3 frames can be actually reside inside the RAM or memory. Okay, so let's say first CPU asks for this data that is available in process page 3. This is 1, 2, 3, 4, 5, 6, 7. Let's say CPU asks for this data that is available in page 3, but this is demand paging technique. So no pages at the beginning, no pages inside the RAM. So CPU asks for this data, but it is not inside the RAM. So okay, one more thing is that, so how you actually decide this page replacement algorithm better or not, better than others page replacement algorithm? How you decide? We can decide this. The page replacement algorithm minimize the number of page fault. Which page replacement minimize the number of page fault? That is actually referred as the good or better page replacement algorithms. From here, we'll count that if we have this kind of paging sequence by the actually refers by the CPU, and if we use the least recently used algorithms, how many page fault occurs? Okay, we use the least square first, then we will check the FIFO, first in first out algorithm algorithms, and then we will also check LIFO, last in by using this sequence, and then we will check the OPR, optimal page replacement algorithm, and count the page fault. And from this, from among these algorithms, actually, which one actually reduce the number of page fault means that that algorithm is the best algorithm. Huh? This is the best algorithm. From how we can evaluate the algorithm performance. Okay, we need to count the number of page fault. Okay, as this is a demand paging, so at the beginning there no pages loaded inside the RAM. So first it asks for this page, asks for this data. CPU asks for this data that is residing page P3. So page P3 is not in here, so it's a page fault. So there will be one page fault here. Let's count one, and P3 is loaded inside the RAM. And next, CPU will ask for this data for P4 that is residing page 4. So page 4 is not currently available in RAM. Only page 3 is available. So CPU also, your OS also send this page inside the RAM. So it is also one page fault. Here is we have page 4, and then CPU asks for this data that is reside inside the page 5. Page 5, yeah. But page 5 is not currently available inside the RAM. So your OS will actually here it's loaded the data for page 5. Okay. So now total count is page fault count is total 3. Now also for process P1, 3 frames is allocated for this process P1. So it's actually fill up this for fill ups its frames, allocated frames. Okay, 3 frames now, three pages inside the RAM. So next is P1 asks for this data that is actually available inside the page number 1. Now actually is a question, the who is page. Here you see the 3 frames is already fill out. So so it's now you needs to actually replace a page for process P1 because page number 1 is not currently available inside the RAM. Okay, then who is page you will replace. In case of least recently used algorithms, from here who is actually page least recently used by CPU. This is recently used. This is after before that one is used, and then this recently used page number 3. So what it will do in case of page replacement algorithm, list LRU algorithm, it will just back this page, rewrite this page inside these decks, and then one will be loaded in place of page 3 in here. Okay, now one in here, also one page fault. So total page fault is now 1, 2, 3, 4. Okay. Again, CPU asks for this data that is inside this 4. It will check that page 4 is available or not. This page 4 is available, so no page fault. It is fine. Then again, CPU asks for this data that is available inside page number 5. You see, and it will check this RAM, and then it will find this. Okay, 5 is available, so no page fault in here. Now again, CPU asks for this data for page 1. Page 1 is here, no page fault. And then again, CPU asks for this data for page 2. You see, here is available 1, 4, 5. 2 is not available inside this RAM. So there is of course there is a page fault. So which page will replace now? Which is least recently used? Currently use page 1. Currently use page access page 1. That one, page 1, and then before it access the 5 as well, and then list and then access the 4. So 4 will be the replaced. Okay, recently accessed is page 1, and then before it accessed the page 5 as well, and before that it accessed the process page 4. So page 4 is the least recently accessed by the CPU. So 4 will be replaced by the page number 2, by this page number 2. So here 4 is not in here, so 2 will be in this slot. So here is also one page fault. So total 6 page fault right now. So now again CPU asks for this data that is reside inside page 4. But page 4, you see, page 4 is not currently available inside the RAM. So it will what it will do, it will replace this one. Okay, 2 is available, but 4 is not available. Okay, so what it will do, it will replace the page 4. Okay, it will replace the page 5, which is recently list recently accessed by the CPU. So here it is 4. Here it is 4. 4 is now. So there is another page fault, and now it see that 2 is ask for this data for that is available page 2. So 2 is inside the RAM. There is no page fault. So how many page fault is if I use the LRU? LRU needs total 6 page fault for this string, page string. Next, check that data for if we use the FIFO algorithm, first in first out algorithm. Let's see how it works. Okay, let me again actually clear this some part of this difference. Okay, okay, so sequence is same. So we have a process P1, 1 2 3 4 5 6 7 1 is 1. This is 2 3 4 5 6 7, whatever it is. And then this is the RAM. Also same as it's allocated for three frames. 3 frames. These 3 frames for process P1. These 3 frames for process P1. Allocates total 3 frames. 3 frames. Now let's see if I use the FIFO. What is FIFO means? You already know. I think you already know about this. What is the FIFO? When CPU requests for a byte or a word that is not present inside the RAM, then OS will replace the page that comes first inside the RAM, inside the memory. Okay, that comes first inside the RAM or memory, whatever it is, it's fine. So OS will replace the page that comes first inside the memory, not accessed. That comes first. Okay. Okay. So let's see how many page fault will occur if we use the FIFO algorithm. Okay, in this scenario. Okay, let's see number 3. At first it will ask for this page number 3 in here. So 3 is not available at it is demand paging, so no page at the beginning, no page loaded inside the CPU. So 3 is not available. Let's say 3 and 1 page fault, of course. And then next it will ask for this page number 4. 4 is not available, so there is also 1 page fault. Then it asks for this page 5. 5 is not available, so 5 is loaded in here. So here is also 1 page fault. Okay, so total 3 page fault. Now it's request for this data for page 1. Page 1 is not available inside the RAM, but 3 frames is already allocated in here. So we need to replace a page. So which page will replace? The page that comes first inside the memory or RAM. So first comes at page number 3. It's very easy to detect. This one is first comes inside the RAM. So we'll replace this page 3 by page 1. So here now, not page 3, now it is available for page 1. And then here is also 1 page fault as it replaces. Next is 4. 4 is available, so it's fine inside the RAM. 5 is available also inside the RAM. Then again 1 is also available inside the RAM. Then again 2 is not available inside the RAM currently. There is 1, 4, and 5. Page 4, 1, 4, and 5 is available. 2 is not available. So which page will replace? Among this, which page actually comes first inside the RAM? Among this, the 4. Page number 4 comes first. Okay. 1 is most recently comes, and then 4, 5, then 4. Before 4 actually. Okay, 4 is comes first. So we will just write back 4, and in this place we will add the page number 2. So 4 is not inside the RAM. So also here is one page fault. And then then 4 actually request for this process page number 4. Now page number 4 is not available inside the RAM. So here is also one page fault. So which page will replace now? Page 4 is not available. So which page will replace? 5 actually first came inside the RAM. So 5 will replace by 4. Here is will be 4 now. So then request for page number 2. Page 2 is available. So total page fault is also 6 for FIFO as well. That is also 6. That is also 6. Okay. Now let's check the LIFO. LIFO is kind of reverse of the FIFO. You know that how it works. When CPU is request for data, same as the previous request for this data or byte not present inside the RAM, then OS will replace the page that comes last, not first. For LIFO, that comes last inside the memory. That page will be replaced by the CPU. Okay, CPU when actually when there is a page fault. Okay. Now let's check for LIFO system. We have total. Okay. Also we check in here. Okay. How about the LIFO? If we use the LIFO, first same thing. There demand paging, no page at the initial. So 3 asks for the page number 3. No, there is one fault, page fault, and then asks for the page 4. Or the page 4 is not available, one page fault, and then 5 is in here. So here is also one page fault. Sorry, 5. There is also one page fault. Now page 1. As for this page 1 is not available inside the RAM. So which page will replaced by operating system? Which page will replace? The page that last comes inside the memory. The last comes is page number 5. So page 5 will replace by page 1. This page 1. Page 1 is here. Page 1. Okay. So one page fault, of course. It was not one was not inside the RAM, so there is a page fault, and then replaced 5 with 1. Okay. Now page 4. Page 4 is inside RAM, so no page fault. Then again 5. Now you see the 5 is not available inside the RAM. Okay, so there is one page fault. Now let's see which page will replace by 5. The page that last comes inside the RAM. Okay, so it will replace the which one last come inside the RAM is page 1. Okay, page 1. So page 1. So page 1 replaced by the page 5 in here. Okay, page 5. Okay, so I already checked this one page fault there. Okay, and then again CPU asks for this data for page 1. We see page 1 is not available inside the RAM. So which page will replace the page? Which page is last term is page 5. So not available. So here is one page fault, and then it will replace the data data 5 with 1. Okay, here is also 1. Here is also 1. Okay, then CPU asks for this data for page P2. Page P2 is not also available. So which one it will replace? The page that last come. This is it will replace the page 2. Page 1 with page 2. Also one page fault. And then 4 is available inside, and 2 is also available inside the RAM. So how many page fault in here? 3 total 7. Total 7 page fault if we use the LIFO system. Okay. Now let's check with the another algorithm, MRU, most recently used algorithms. It is opposite of least recently used algorithm. That one. It is these two algorithms is opposite to each other. These two. Okay. Least recently used, from this name you can understand, and most recently used. These. Okay. How it's work? Most recently used algorithms. When a CPU requests a byte or word that is not present inside the RAM, then OS will replace the page that is most recently accessed by the CPU. In case of list LRU, least recently accessed by the CPU. In case of MRU, most recently accessed by the CPU. This page will be replaced. Okay. So now let's check that how many pages fall for MRU algorithms. Okay. Okay. Now check this. We have this sequence, and at present no page inside the RAM because it is demand paging system. So it asks for this data page 3. Page 3 is not available, so it is a one page fault in here. So 1, and page 3 will be, OS will send this page 3 in here. Then page 4 is not inside the RAM, so there is one page fault. So page 4 is in here. OS actually allocates the memory page 4 in this slot, let's say, and then page 5 also not available, so page 5 also allocates memory in this slot. Okay, also one page fault. Now it asks for the 1, and 3 frames is fill out, and then already fill out, and then it asks for this data in page number 1. So page number 1 is not available. So which page is accessed by the CPU recently? Recently, it is nothing but page 5. Okay, so here page 5 will be replaced by page 1. Page 1, of course, one page fault in here. Okay, and then next 4 is inside the RAM. It is fine. Then 5 is not available inside the RAM. So which page will be replaced right now? The most recently accessed page is 4. 4 is accessed by the CPU. So page number 4 will be replaced now. Page number 5. Okay, page number 5. That is page number 5 will be again here. So one page fault, of course. And then CPU refers the data for that is inside the page 5. Or the page 5 is inside the RAM, so there is no page fault. And again, CPU will ask for this data that is inside, that is actually available, that is inside page 1. Page 1 is also inside the RAM. It is fine, no page fault. Again, CPU asks for this data for page 2. But page 2 is not available inside the RAM. So what it will do? It will replace the page that is recently accessed by the CPU, most recently accessed by the CPU, which is nothing but recently accessed page 1. Page 1 is recently accessed. So page 1 replaced by the page 2. Page 2. Here is page 2. So one page fault, of course, in here. Now CPU will ask for this data that is available in page 4, but page 4 is not inside the RAM. So which page it will replace? It will replace the most recently accessed, which is nothing but page 2. So page 2 will be replaced by, of course, one page fault here, replaced by page 4. Of course, we will count the one page fault in here. And then CPU again asks for this data page 2. Page 2 is not available inside the RAM. So there is one page fault, of course, one page fault. And which page will replace? Is recently accessed by CPU, page number 4. Page number 4 will be replaced by page 2 in here for most recent access algorithm. So this is how actually it completes the sequence. So how many page fault for MRU? Total 8 page fault. Okay, total 8 number of page fault. Total 8. Now let's see our next algorithm is called the optimal page replacement algorithms, or OPR. How it works? When a CPU requests a byte or word that is not present inside the RAM, then OS will replace the page that will not refer by the CPU near future. What does it mean? Actually, it will predict the future. It will actually look the future pages. If it is not if CPU in near future, if CPU not refer this page, then this page will be replaced. If a page CPU actually look the predict the future pages, look at the future pages, near future pages, that actually it will actually trying to access the data near future from this page. This page will not be actually will not replace. Okay, let's see how it's works, then it will be more clear. Let's see, we will use the same examples. We have this data. Let me clear some parts, it is more. Here is one. This is the one. Here is frame one. Here is page 5. Okay. Okay, now it's fine. This is 5, page 5. This is page 5. This is 1. Okay. This is 2, 4, 2. Okay. Now, how OPR works? Let's see how CPU OPR works. Let's we have same thing. How many page fault will be there? We'll count. First, your CPU asks for this data, page 3, but it is not available. So it is of course one page fault. So 3 is placed in here. Then 4 is not available. So one page fault. Then 5 is not available. So there is one page fault in here. Now let's see the CPU asks for this data for page 1. So which page will replace? Then CPU then actually your operating system look at the in future which page actually CPU you are trying to access. From here you can see page 4 and 5 will access by the CPU in near future. So optimal page replacement algorithm doesn't touch this page 4 and 5. It will see that here it will see this 4 and 5 is available inside the RAM. So it will not touch this 4 and 5 because CPU will refer this two page near future. So it will not actually replace these 2 pages. So what it will do, it will replace other pages. So here it will replace the page number 3 by page 1. Okay, because CPU your operating system knows that CPU will ask for this data 4 and 5 near future. Okay, so here it will replace the page 1 will replace by page 3. Okay, here is page 3, of course one page fault. And next page 4 asks for this, refers the data for page 4. Page 4 is inside the RAM, no problems, no page fault. And then asks for this data that is inside page 5. Page 5 is in here, so it is fine, no page fault. And then again asks for this data page 1. You see page 1 is also available inside the RAM, so no page fault so far. And then CPU asks for this data page 2. Page 2 is not currently available inside the RAM. Then what OPR will do, optimal page replacement will do, it will look the near future. Which page will be accessed by the CPU near future. In here you see CPU will trying to access the page 4 and page 4 and 2. So 4 is available, so it will don't touch the page 4 because it will access near future by CPU. So 4 will not touch and 2 will not touch, but 2 is not inside the RAM. Now actually it's request for this data for 2. So here instead of 4, your OPR, your OS can replace either page 1 or page 5 because these are not actually accessed by the CPU near future. So any of them can replace, no problems. So let's say CPU your operating system replace the page 1 by page number 2. Now again 4 is inside RAM, so no problem, no page fault. Oh, here is one page fault because 2 is before. Okay, in here one page fault. And then again 2 is inside the RAM, so no page fault as well in here. So now how many page fault for OPR? OPR actually gives you the total number of page fault, 5. Okay. So by using within this sequence, Also, if you use the 5 different algorithms, you actually evaluate the total 5 different algorithms, and from here you can see that optimal page replacement algorithm provide the best result. This is the best algorithms, optimal page replacement algorithms. Of course, if you implement the optimal page replacement algorithm, it will always give you the best result. Always give you the best result. It is the best algorithms for in case of page replacement. But problem is you cannot actually practically implement this type of algorithms. Why? In here you need to actually predict the future. In near future, which page actually your CPU wants to refer in near future means you have to look at the future, but we don't know. We don't actually exactly know that which page will be referred by the CPU in near future. We never know this kind of phenomena. Okay, we never know this kind of. We never actually make the 100% accurate for any prediction result. Okay, there will be some error. So we cannot actually practically implement this kind of optimal page replacement algorithms. Okay, we cannot do this, even though this is best algorithm, but we cannot predict the future accurately, 100% accurately. So we cannot do this. Okay, OPR practically implement this OPR algorithms. But from this OPR, but it is, of course, it is the best result and best algorithm. And from this algorithm, what you can do? You can do one thing. You can consider as a benchmark. This algorithm you may consider as a benchmark things. From these algorithms, you can decide that which one actually works better. In case of this page sequence, you see that OPR provide you total 5 page fault, and then LRU and FIFO actually give you 6 and 6, total 6. Actually, it is very close to your OPR algorithms, least recently used, and also FIFO. So also, and then actually MRU is actually very worst, and then LIFO is also, performance is not good. So from here you can see that you can use that you can actually conclude that LRU and FIFO actually give you some optimal result as OPR algorithms. So OPR can be used as for benchmarking for other algorithms. Okay. Okay, so from these 5 algorithms, of course, optimal OPR is the best, but we cannot actually implement practically because we don't know, we can't predict the future 100% accurately. Okay. Okay, these are the 5 algorithms. So, okay. So this is the actually last topic for our memory management systems. In our memory management systems, we started from the beginning, some introduction, and then memory management systems. So these are the last topic for memory management system. So in your syllabus, you can see I just changed some. At first, first topic was the process and thread, and next topic was the memory management. But I just changed this topic. At first, I just give you some idea for memory management system. Then actually I had planned to give you the process and management. So next week we'll start a new topics like process and thread, how CPU handles this, how your operating system handle all process and threads. This kind of stuff we will discuss from our next weeks. And one more announcement is that I already scheduled your first midterm exam, first midterm. Hopefully I'll it will be Thursday. It will be Thursday. Let me clear everything. Then you can understand to be. It will be Thursday at 3:02. This date, okay. From now to from here to 2 weeks later. today is 16. So 2nd March. 2nd March will be your first exam. So total I decided it will be total 30 questions. Total 30 questions. All are MCQ and true false. True false. And 30 questions I give you total. Every questions I give you total 2 minutes. 2 minutes. So total 60 minutes. Okay, I hope this is good enough to complete your exam. So exam will be open at 2nd March for whole day. So you can actually go for exam anytime, but you will get to exactly 60 minutes. Okay. So if in case if you have any problems and regarding anything, you can ask me. Okay, immediately. Okay. So this is the important announcement, and for preparations till today is the syllabus that actually covered till today. So this is the syllabus for mid 1. From next week, what we learn, then this syllabus will be for mid 2nd, not mid 1. So mid 1 syllabus will be till today that we cover only introduction and memory management. Okay. In memory management, I may highlight certain topics like first we talk about the multi-programming operating system and multi-processing operating system, this kind of stuff. Also some how CPU actually interact with different kind of memories. Okay, I may ask you that central CPU can directly access to SSD hard drive. It is true or false? It is false. Like CPU cannot directly access the SSD. CPU can directly access the RAM. Okay, this kind of stuff. And then we talk about the multi-programmings and some different type of addressable system. Let's say when every word inside the RAM has its own unique address. What does it mean? When every word inside the RAM has its own unique address, means that this is word addressable system. Okay, this kind of stuff. And then we actually continue with some address space like physical address space and logical address space. And next we talk about some partitioning things, contiguous memory allocations and non-contiguous memory allocation. There is two important things: fixed partitioning and variable partitioning. These two concepts we learned. And then we talk about some algorithms like memory allocation algorithm, first fit, best fit, worst fit, and also next fit. This is very important topics for your exam. You may get some question from there. And then paging is of course for example, in contiguous memory allocations, always maintain in case of paging method, you always maintain a page table. For in case of contiguous memory allocations method, you always maintain a process table. Okay, these things is very important. You may take care of this. And then paging method, and then of course the different page table entry. Today I also talk about the different page table entry like reference bit, dirty bit, frame number, what actually it exactly means. And then virtual memory, and we cover some frame allocation algorithms like equal frame allocations and frame allocation based on the process size, this kind of stuff. And today we talk about some page replacement algorithms is LRU, MRU, OPR, and FIFO, LIFO. Okay, these are the syllabus for mid exam. first mid exam. So total 30 questions, you will get total 30. This is also total 30 marks for 30 questions. And let me stop my sharings, and okay, let me share one more things with you before we go. So for preparations, in case of preparation, you may go for modules, and then I already said this mid one. It is not actually available. Currently, it is not available because it will be available till from second March. Okay. From my side, I can see, but from the student you cannot see this. Okay. Now, for in case of preparation, what you can do, you can, of course, you have to actually read carefully this module one, like underscore additional, this PowerPoint. Of course, this PowerPoint, carefully read this module on this additional. Okay, this is the summary of my lecture, and this big actually PowerPoints. Okay, this is the summary of my lecture as well as this PowerPoint. Okay, this module on additional, these additional items you need to read carefully for taking preparation. Of course, if you don't understand any parts in this PowerPoint slide, then you can also look the video lecture as well from here. Every video lecture is available inside the module. Okay. So, and of course, you prepare for this module 3 additional and module 2 additional part 2, this kind of stuff on module 3. Okay, this will give you the good preparations for your next exam. Okay, so any questions or comments regarding the exams? Okay, so if you have any question or comment, you can ask me, because we have times next couple of weeks. Okay, so we may stop here today. Okay, see you okay next week. Have a good weekend and have a good night. Thanks, Smith.